Good evening. I will write one more program. Write a program to print the factorial of a number using function. As far as factorial is concerned, there is no library function. We have written that factorial. So what would be the prototype of a factorial function? Factorial function is going to return a factorial, which is an integer. So there should be int as the return type of function. As far as function name is concerned, you can give factorial because it is not a keyword. Right? And the function will take one argument of which factorial is to be found. So factorial is obviously of integer number, so int, right? So this is a prototype. Factorial is the name of function. It is going to take one argument. It is integer argument and it will return integer. That's it. Right? So I will declare one variable as a num. I will declare one variable as a fact, suppose. Right? I will take the input from the keyboard. So enter number. %t and num. Right? Now, in the past, I think probably in the function chapter, you might have written the program to find the factorial of a number. But now we will write our own function, separate function, which can be used by yourself or any other programmer. So I will write fact is equal to factorial. Send the num as an argument, right? And I will write here %d factorial equals %t, right? And I will write num and fact. Here I will write the function definition. So int factorial, I will write here x. I will declare one variable as I. You can write for I equals 1, I less than or equal to x, I plus plus. Because int f is equal to 1. Right? I don't need to explain this code to you because f is equal to f into, what I can write I. You can write I, right? It work. Let's check. Return f. So there is no warning or error. So I will run the code. Suppose factorial of 8 40 3 20. It might be correct. We will check for the number of which we know the factorial. We know the factorial of 5 is 5 factorial is I think 120. Yeah, 5 factorial equals 120. Right? So this program is all about a factorial, but we have written that program using functions. Now how this code is executed when you send any number. This is actual argument. This is we are collecting an informal argument x. we initialize. This initialization is very important because we are going to multiply that by each value of I till I is less than or equal to x, right? Because factorial of 5 is either way, 1 into 2 into 3 into 4 into 5, or other way around, 5 into 4 into 3 into 2 into 1. Now here we are trying to find the factorial from 1 onwards. So 1 I is equals 1 and f is also 1. So 1 into 1 value of f. If you want to debug this code, I put the cursor on, suppose, line number 9 is not required. I'll keep the cursor at the line number 15 directly, right? Instead of printf, scanf, we know all these things. So I'll put the run to cursor. So since I have entered run to cursor, this is output window, right? And printf function has been executed. So since this statement has been executed, it has given the message on the console, that is enter number, right? And right now the control has gone inside scanf function. So that function is accepting some number from us. So let me enter, suppose 5. As soon as I press the enter key, 5 will be stored in the variable num, and now again debugger will take control of the program and control will reach at line number 15, right? So observe this carefully, right? Now here no activity is there because I mean here the control will pass only when control comes here, right? Something is to be printed. At that time control will come transferred to the console window. Till that moment control will remain here only in the program. Now this is a function call, as I told you. So this is a variable to collect the value returned by the function. So that's why we have written fact is equal to factorial. Now when control reaches at line number 15, it will go at the right hand side first. The question is why at right hand side? It will go at the right hand side only because there is a assignment operator. Assignment operator has got the lowest precedence. Lowest precedence. That is, I mean, there are two reasons why control goes here, right? Because we should know that if we are a C programmer, we should know that. Rather, we are a programmer, we should know what happens at each statement level. So when control comes here, line number 15, the control goes directly here. It doesn't go here. Reason is there are two reasons. First reason is that this is an assignment operator. Assignment operator in a precedence table has got the lowest precedence, last, right? On the contrary, if you look at the precedence table, the function has got the highest precedence. That is the reason this is executed first. So if I now here there is a debugger menu, right? So this is debug. Here run to cursor. Here it is the next line. Here it is a step into. That means inside that statement. Here step out. If you have gone inside the some function, you can step out of from that. And this is step into instruction. So now I will ask debugger to step into so that this called. So I will press step into. So it will, the control will go, that yellow marker will go at, I think, line number 14 or maybe at directly at line number 27. No, it goes at the line number 25. Why? Because we have initialized that. We have initialized that variable, right? Now if you go to the watch window right now, right, debugging windows are there. I will go to the watches. Okay, what are watches? If you can observe here carefully, As far as control is inside this function, here there is no information about num and fact, right? So here there are two types of variables. One is a function arguments. So x is a function argument. The contents of num, which we have entered as a 5, that 5 has been copied to the x. You can observe this. 5 has been copied to the x. That's why it gives you x, contents of x as 5. And these are local variables of the function. So I contain some garbage value because we have not initialized that, and control goes here only because as far as f local variable is concerned, which is integer, we have initialized that to 1, but this statement is yet to be executed. That's why it contains the garbage value as 0, right? So if I go step into, right, it will go to the next statement, and now f contains 1, right? So this statement is yet to be executed. So it will go on executing. You can check that how value of f and I are getting changed for each iteration of the loop. Okay, value of I and f will go on. So value of I will become 1 first. So I will go step into, right. So now value of I is 1, f is 1. So f into I, that is 1 into 1. Value of f will be again 1. There is nothing big in that. Now value of I becomes 2, right? The moment I press step into, value of I will become 2, right? And that 2 and earlier value of f, that is 1. So 2 into 1. So f will contain now 2, right? Value of I will become 3 and f will contain now 6. Value of I will become 4 now and f will become 24, right? The value of I becomes 5 now and the f will become 120, right? Now here value of I will become 6. 6 is greater than x. And we have written the condition, right? Execute loop till I is less than or equal to x. So the condition will become false and control reaches at line number 29, right? And here f contains 120, so that value will be returned to the calling function, right? So you can check. I will if you want to see the call stack, this is the call stack, right? So you can observe here there is a main function and there is a call stack, right? So as soon as since control is at the return statement, as soon as I place the step into, the factorial function will be popped off because control is returning to the calling function. So observe that carefully, everything, that yellow marker as well as main program as well as call stack as well as watches, everything you have to observe here very carefully at a single moment. You have to see everything. Rather, you have to observe everything, right? So I will place step into, right. It is yet to be executed. Return f has been executed, but control has not yet gone outside the function. So now control will go outside the function. So function has been popped off. There is no I, there is no f, but this information is about everything about the main function because control is inside the main function. Here num is 5 and fact is 120. That means whatever the value was returned by the function, it was assigned to variable fact, and this statement is yet to be executed. It will be executed and it will give the output. See, it has not given yet output. So I will again press the step into. Okay, it went inside the, I told you, as far as printf and scanf functions or any library functions, predefined library functions are concerned, do not use the step into. Here I will, if you by mistake, because mistakes are committed, okay, even I make me a lot of mistakes. So here I will come outside the this function, right? Step out. So I came back to the calling function, and here you can see the output 5 factorial equals 120. So this is how the program is executed, right? So I will come outside the function, right? That's it. So no HS is there, nothing is there here now, right? What happened? Stop the debugger, right? So this is about something about the functions. I mean, a factorial function. Now, so I'll start the recursion here. Here, this is a new chapter, recursion in C. Recursion is basically the mechanism in which the calling function and called function are same. That is recursion, right? Like in the earlier program, we called that factorial function. Main was calling function and factorial was called function. There are, this is a special case where calling function and called function both are same. Likewise, you're calling main from the main function, right? Or you from main function you are calling some function, okay, and that function itself gives a call to that function again and again and again. So that mechanism is called a recursive mechanism, recursion. A very interesting methodology. First of all, very interesting mechanism, function calling itself. It is very interesting. Question again is why it is necessary. There are some situations in life where recursive mechanism you can observe. First thing. Second thing, there are a few programs, there are a few problems rather in the computer industry which can only be solved using recursion. See, recursion is basically strictly we cannot say alternate mechanism, because many students say that recursion, is a kind of a loop. I don't believe that. It repeats, certain part of the code is repeated, but still it is not a loop. Still it is not a loop. It is completely different and interesting mechanism. So basically what we have written, that factorial function, that is a non-recursive function, and to find the factorial we have to use the loop, and we will try to solve the same program using recursion now, because we have to, now we can write, we can use the recursive mechanism only when certain pattern is there. Suppose a factorial has got some pattern, right? So 1 into 2, 1 into 2, okay, result of that 1 into 2 is, suppose, whatever, okay, we know that it is 2, but let it be whatever. Then that result is multiplied by one next number, okay. See, recursive, mathematically factorial is, I think, defined in a mathematical formula as n into n plus 1. Right? N into n plus 1. So suppose n factorial is n into n minus 1 factorial. Now that n minus 1 factorial will be what? Again, the same formula, n minus 1 into n minus 1 again factorial. So that is a kind of a recursion, right? I will show you on the whiteboard. So how we define the recursion in mathematics? N factorial, right, equals n into n minus 1 factorial, right? But, and this has got this formula, right? So, but again, this has got same formula like this, right? So what it would be? N minus 1 factorial is, this will be expanded as n minus 1, right, into n minus 2 factorial. So what will be the ultimate at this level? There should be n multiplied by n minus 1 multiplied by this n minus 2. But not n minus 2, n minus 2 again factorial. So up to what it can reach, right? Till n doesn't become less than 1, right? So that's why 5 factorial is 5 into n minus 1 is 4, n minus 2 is 3, n minus 4 is 2, n minus n minus 1, n minus 2, n minus 3 is 2, n minus 4 is 1, and n minus n, that is 0. That is not valid. So this is a kind of a, so you can observe this is a kind of recursion. N into n minus 1, again this is expanded, so n minus 1 into n minus 2. So this is a repetitive, okay, some kind of repetition is there. So we can convert this program into recursion. We will first of all write that program, and I will explain you in detail, right? So a lot of recursive mechanism is there. So first of all, let's go through some theoretical aspects of recursion. So this is also recursion. I forgot about these images. If you look at the tree, okay, there is a root, then branches, then sub branches, there is sub branches. So each of that sub branch is a smaller version of that tree. Okay, huge tree is there, right? There is a smaller version at each point. At each particular point, there is a smaller tree. So each of that branch again, it is a smaller tree. So that is a recursive mechanism you can find in the nature. Nature loves that recursion. Okay, you can find a lot of recursive examples in the real life, right? This left hand side there is a triangle, so you can find there is a huge triangle. Then number of small triangles are there. Again inside that small triangles are there, right? So again it is a kind of a recursion, right? A lot of examples are there. Then recursion versus iteration. Okay, so this is the stuff which basically students like, so that they can face interview or they can face the viva or they can write something on the paper there. So that's what perhaps I have put it. Okay, I do not give personally. I do not give this. Even any importance to this kind of theoretical stuff. My focus always is on explaining that and understanding. Okay? So that no student should be able to write everything in their own words, not from the book, not from the internet sites, not from, okay. We should develop our own thinking and converting that thoughts and understanding into your words. That is how one should face viva. That is how one should answer questions in the interview. That is how one should write answers in your theoretical paper as well, right? Okay, fine. So generally recursive solutions are simpler than or as simple as iterative solution. That is true. Okay, recursive solutions are simpler or more simpler than iterative solutions. I will write one program at the same time. I will give you some programs for assignments for writing. Okay, programs using recursion. There are some problems in the world in which one solution is much simpler than the other. Yes, there are some problems in the world. The recursive solution is far simpler than the iterative solution. Hmm? Generally, recursive solutions are slightly less efficient than the iterative ones. That is also true. Why? I will explain you. Recursive solutions are not efficient. Hmm? They are space consuming. Space means memory, more memory is consumed, right? There are natural recursive solutions that can be extremely inefficient. Be careful, right? So be careful means if any particular problem we can solve using iterative method, then avoid recursion. Unnecessarily, you should not go for the recursive mechanism. Okay. For writing some assignments to understand recursion, you can use the recursion. But when you start working in the industry, avoid recursion. Right? But sometimes you cannot. Rather, sometimes you cannot use the iteration, but you have to go for the recursion. That is very interesting, right? Then types of recursion. Okay, single and multiple. I will talk about this afterwards. No, I don't want to waste time today because we have got just 15 minutes. There is a single and multiple recursion. I will talk about that afterwards, right? Perhaps tomorrow. And direct recursion and indirect recursion or a mutual recursion. This is basically a theoretical stuff. I think C programmers should not go into that, right? Understand the recursive mechanism and forget. Uh, Identify the base case. Yeah, this is very important. Not basic case, it is a base case. I have made a typo mistake. Identify the base case. Identify the non-base case, right? Identifying the terminating condition on the basis of basic case. Maybe I don't know. I have forgotten that base case or basic case. Then behind the scenes, uh, now each time a function is called, a new instance of function is created. Each time a function returns instance, the creation of new instance only requires allocation of memory space for data. This I will explain you in the while writing program. Okay. Factorial using recursion. Okay, same program is here, right? So this I will also explain when I write the program, right? Typical applications, lot of there. I forgot all these things. Okay, you are going to solve these applications, right? But not all. And as of now, you cannot write all of them. But you can just now see the importance here. Okay, factorial of a number that we are going to write, power function, Fibonacci sequence. Fibonacci sequence, you know that. So Fibonacci sequence is one of the good example of because that is a recursive 1 0 1, then addition of 0 and 1, so again 1. So any number is addition of previous two numbers. So this is recursive mechanism, right? Then Tower of Hanoi. I don't know whether you have heard about the Tower of Hanoi or not, but it is very interesting concept, very interesting mechanism. It has got connection along with the India, surprisingly. Okay. I will show you that. Then collage sequence is there, very interesting. I will show you that, or you can Google that. Sum of all digits, very interesting. Okay. Sum of all digits again is a recursive mechanism. Printing the string in a reverse order. This is also interesting. I will show you this one as well. Okay. Then binary tree travels. This is not possible using function. This iteration. Iteration means loop. Binary tree traversal has to be done using recursion. Okay. What is that binary tree? I will talk everything about it so that you understand this. Then finding the binary equivalent of integer. Binary equivalent means that um, uh, any number who's converted into 0 1 0 1 format. So that is possible using recursion. finding the digital root of a number. That is very interesting program. Then greatest common divisor is there, binary search, file system traversal. All these are typical applications of uh, recursive mechanism. I will copy this. Right? And I will create a new project. Factorial. I will give the name as R factorial. Right? I mean factorial using recursion, so that there is no question of creating a duplicate file with same name, right? So factorial of a number, I will write using recursion. Right? So name will be same, right? Changes will be inside this. Right? Loop won't be there. I think initialization is not also necessary. I don't remember the how to write, but I will write if or what if x is equal to 1, return 1. Right? Else, I'll write f is equal to mm, yeah, f is equal to into let me execute the code first and then I will explain you. I don't know whether code is correct or not. I have to test that. Yeah, code is correct. Code is correct. Okay, fine. Question is, how does this program execute? Now see here, main is a calling function. Main is a calling function. Inside this, we have called the factor. This is the same program earlier. I mean, as far as this code is concerned, it is same. No changes are here. But last time we sent the num, right? Here. Should I open that code as well? I'll open that one also. Okay. So last time what we did send a number entered by the user and collected here, and we wrote the loop. Right? Inside the loop, we found the factorial. What we are doing here, we are sending that number, but we found that there is a recursive mechanism. So 5 factorial is 5 into again 4 factorial, right? 4 factorial is 4 into 3 factorial. So that is a recursive mechanism, right? If earlier program is to be written the way mathematics solve that, okay? Suppose in mathematics we say that 5 factorial is 5 into 4 into 3, sorry, into 3 into 2, 1. That is 5 factorial. In the same way program is to be written, then we have to write I is equal to X, right? I greater than or equal to 1, right? And then I minus minus. So this little some small changes need to be there, right? So you will get the same output here. What happened? Okay, sorry. I is equal to X, I greater than or equal to 1, I plus plus. So this will give you the same output. 6 factorial is 720. Right? But this loop executes in this fashion. Right? Earlier was getting executed in this direction. 1 into 2 into 3 into 4 into 5. Okay. So this is actually basically this is the right way. So this is more appropriate way of writing program. More appropriate. The way we calculate the factorial. So this is the appropriate way. Fine. Now here what suppose we send the 5. So X contains 5, right? So there is a variable F, right? Now what we have written, where this process stops when X becomes 1, because 1 factorial is 1. Even 0 factorial is also 1, right? You can write here X is equal to 0 as well. That is important, right? Fine. Forget about this. This is basically what you can say. This is must. This is must. Why? I will write another program. Recursion basics, right? Where is that? Okay, suppose I call here main function. What will happen? It will give some warning, I think. No warning is there. Right? If I run this code, what will happen? See this loop, this program is getting executed and printing hello world, hello world, hello world. You cannot know how many times it has printed hello world, but still it is printing. Okay. How long it will print? Till the end of the world? No, it will not print till the end of the world, but it will go on printing. I mean, you will get tired, but the computer won't get tired. The reason is that I have to abort this, right? I have to abort this. This is we have aborted that program when the code was running. That's why it gives you process terminated with status, right? Status. This is minus some negative value has been written, right? 0 minutes 44 seconds, right? Now this is basically a recursion. There's nothing wrong in this. Okay, int main printf main. So inside main has been called. What happens? Control never reaches here. That's why program doesn't terminate. So while so when you write a program using recursion, you have to make a provision which will let control to escape out of that, no, or to stop somewhere. That is very important. Here, what happens? This is printed, right? And then again, control calls this main function. So again, control goes here. Okay, never stops. It never stops. That is a recursive mechanism. That is the reason we have provided here some mechanism. Okay? So whenever you write function using recursion, make sure that you have kept the escape route. If you don't keep, no, you will go into the infinite, never-ending function calling mechanism. Right? So here there is no escape route. Okay, no escape route. Here there is this is a escape route. This condition is the escape route, right? So as soon as the value of x becomes 0, okay, what to do? Return 1. And in the else part, I have how I have written the statement as f is equal to x into factorial x minus 1. So what happens? Suppose value of x is 5. So it is 5 here, right? 5 here. But 5 multiplied by here factorial of x minus 1. So what is this? What is this part? This is a function call. Same like this. There is no difference. Here factorial num, here is factorial x minus 1. No difference is there. Here, if you enter 5, function will be called with 5 as an argument. Here what happens? This again function will be called with 4 as an argument. That's it. So again control comes from this point to this point. Right? And that keeps repeating till what? Till the value of x becomes 0. Okay. When value of x becomes 0, because that is our mathematics rule says return 1. Right? So this is how this function is executed. Now, question is why the output of the program is not 1? Because we are returning 1. Right? When the value of x becomes 0, you are returning 1. Okay. So why you don't get output as 1? That is a question for you. We will discuss that tomorrow. Right? And we will continue recursion tomorrow. Right?